8.1 Sequence and Summation Notation. Find the indicated sum. All right. So this is a sigma notation. This is a sum. It's going to go from, this is the beginning, right? And this is the end. And what you're going to do is you're going to plug in different values of j starting with 1. So the first one of this sequence is basically just going to be 11 times 1. And then the summation means you're going to move on to the next digit. So after 1 comes 2. So then we're going to add the next one, which is going to be 11 times 2 plus, and the next number is a 3. So then it's going to be 11 times 3. And the next number is going to be 4. So we're going to have 11 times 4. And the next one's going to be 5. And the next one's going to be 6, right? So 11 times 1 is 11. 11 times 2 is 22. 11 times 3 is 33. 11 times 4 is 44. 11 times 5 is 55. 11 times 6 is 66. And then we just add all those together. Gives you 231. And that's it. Move on to the next one, same kind of pattern. You're going to start with a 1, and you're going to keep going until you get to 6. Okay, so this is going to be 6 times 1 to the third power plus 6 times 2 to the third power plus 6 times 3 to the third power plus 6 times 4 to the third power plus 6 times 5 to the third power plus 6 times 6 to the third power. Okay, so the first one is 6 times 1 to the third power, which is 1, plus 6 times 2 to the third power, which is 8, plus 6 times 3 to the power, which is 27, plus 6 to the fourth power, which is 64, plus 6 to the, plus 6 times 5 to the third power, which is 125, plus 6 times 6 to the third power, which is 216. You're going to need a calculator for that. All right, so 6 times 1 is 6. 6 times 48. 6 times 8 is 48. 6 times 27 is 162. 6 times 64 is 384. 6 times 125 is 750. 6 times 216 is 1,296. 6 plus 48 plus 162 plus 384 plus 750 plus 1,296 is 2,646. Okay, so now this is the same kind of pattern, except we're going to stop at 5 in this one. So we're going to take the first one, which is 1. So 1 factorial over 1 minus 1 factorial, which gives you 1 factorial over 0 factorial. 1 factorial is 1, 0 factorial is 1, 1 divided by 1 is 1. So next we end up with 2 factorial over 2 minus 1 factorial, which gives me 2 factorial over 1 factorial, which just gives me, expand the 2 factorial to 2 times 1 factorial, put that over 1 factorial. 1 factorial cancels with 1 factorial, give me 2. Next we would do 3 factorial over 3 minus 1 factorial, which gives me 3 factorial over 2 factorial. Expand the 3 factorial until you get 3 times 2 factorial over 2 factorial. 2 factorial and 2 factorial cancel out, leaving you 3. Next one is 4 factorial over 4 minus 1 factorial, which gives me 4 factorial over 3 factorial. Expand 4 factorial until 4 times 3 factorial over 3 factorial. 3 factorial cancel out 3 factorial, leaving 4. Now we have the last one to 5 factorial. Now most of you can already see the pattern anyways though, right? So just 1, 2, 3, 4. So next one's going to be 5. Excuse me. So you have 5 minus 1, which gives you 5 factorial over 4 factorial. Expand the 5 factorial to 5 times 4 factorial. And you put that over 4 factorial. 4 factorial cancels out 4 factorial, leaving you 5. Now you have to add all these together, right? So it's just basically 1 plus 2 plus 3 plus 4 plus 5, right? 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15. So this whole thing goes to 15. So we express the sum using summation notation, using 1 as the lower limit of the summation and I for the index of the summation. Okay, so we're just going to copy this sigma notation here. Right, so we're going to make one of these. Right? So we do the sigma notation, try to make it pretty. They want us to use I for the index. Okay. Now what are we going to start with? Well, we're going to start with 1. And what are we going to end with? Well, we're going to end at 30. Okay, and all they're really doing is just adding the i's together. So it's just the summation of all the i's.